Hey everyone! Today I would like to talk about an important topic, something we encounter all the time when we work with our customers or with people out from the community asking the same question: how is Pulumi working in a cloud-native world? So, before we dive into the topic, let me quickly introduce myself. So my name is Engindiri. I'm working as a customer experience architect here at Pulumi. I like everything about cloud transformation and cloud enablement. This is something I always do, and I really enjoy talking with our customers or people inside the community about this kind of topics, and of course continuous everything. As you can see in the bottom, there are some of my socials, so feel free to follow me and ping me. I'm also in the community Slack from Pulumi, so you can ask me also questions there. So as mentioned before, this video is a follow-up on my recently launched blog post. Head over to pulumi.com/blog and you will find my post with the same title, Pulumi in a Cloud Native World, and you will see a little bit more details around the code, for example, I created, and some implementation details. Here in this video, I'm going to focus on a demo where you see everything running on a holistic view, and also giving you some insights of the motivation. Why do we need an IDP, for example? What is the reason behind this? So let's jump into this. Everything starts with a problem. We're engineers. We're here to solve problems. So let me show you what kind of problem I would like to show you and give you also then the solution for this problem. So in this case, this should be quite familiar for you. This is a typical CI/CD workflow. Take it, leave it with some of the items. Maybe you have them already in place, maybe not. But it should give you a typical overview. So we have, of course, on the left side, we have different entities inside the organization. We have the operation SRE team, we have the developers, we have the security team, and everybody works a little bit on their own. So we have the developer team creating the code, committing it in a source repository, and the moment the source repository gets an update, for example, in a specific branch, the CI system kicks off, creates an artifact, and this artifact gets then in a perfect vault deployed on the infrastructure. And then we have, of course, the operations team, SREs, who created some automation and infrastructure as code around this, and delivering the application to the specific environment. And of course, the security team also taking care here that everything complies and follows specific rules. And of course, which is also important, that we have some supporting tools, for example, load testing and monitoring. So this could be a typical flow you already encountered and you may already have it at your place. So now comes the big question: what could be some possible tools, and what could be something we can add to the specific boxes? So what is a perfect CI/CD? What is a place where we're going to store our artifacts, and so on and so on. Luckily, we have, of course, here the CNCF, which provides a huge selection for different tools and give us a good overview and say, okay, look, here in the scheduling orchestration, we have tools, for example, Kubernetes, or we can use a key value storage. All the stuff everything is written here. But as you can see, this is quite a large selection of tools, and you have to know what tool to select. And now think about this, working in a big enterprise environment, you have to do the tool selection, and it's not a tool selection you do every year. So if you're committing on the tool, you have to stick to this tool for maybe several years. You have to train your whole organization, not only the developers or the operations team, maybe other parts of the organization you have to train to use the tool. So you can see that's quite a large investment. And of course, things are not that easy, as I mentioned before, like, hey, this is the workflow. Now we have different environments. For example, we would like to deliver the application. So we have in the top left, you can see we develop, for example, a serverless infrastructure in different clouds. So we have a Lambda, we have Azure Functions, and all the stuff around a serverless environment. So we need to build our application and then deliver it there. There's different ways to do this. On the right, we have the people, for example, deploying everything on Kubernetes. So there's also a specific way to build and deploy your applications, so your application logic on a Kubernetes cluster, for example. And then any other infrastructure. So think about people using some app services or Fargate and all the stuff, depending what our cloud providers are giving us. So we have a multi-cloud approach also here. And then, of course, on the right bottom side, it can be possible that we have different stages coming on top of it. So not only one cluster, but then we have several clusters for the different environments. So this is, of course, heavily connected here with head age. So what could be a possible solution? And of course, there are people who thought about this, people who are definitely smarter than me and who come up here with some maturity level and say, okay, where are you and what you need? So let's start with the first level. So it's the ad hoc level. Luckily, this is something I don't see so much anymore at our customers. This is in the community at all. So people already realize this is something which is not sustainable. People working on this, but the ad hoc level is defined here as to say, okay, teams across the organization doing ad hoc implementation, they do what they want, what they thought it's the perfect way to do this. They use different tools, different frameworks across the teams, and maybe also have different processes in place. So first level ad hoc, and luckily 2024, not something you will encounter so much, but hey, still, there are probably organizations outside which do this, and they start, and now we come to the next phase. They start to think about, okay, it's something we cannot do anymore. So every time a team introduces their own stuff, when people switch between teams, things gets complicated. They need to retrain. There's nothing they can take over from one place to another and can be ramped up in a very short time to be operational, to say, okay, I switch team A to team B and now I can start because I know that the CI/CD approach is always the same. So this is something people realized, and now we come to the proof of concept stage. So people start, DevSecOps implementations are planned, teams get trained around this, and they start to make a tool and process selection, and some POC teams start to work around this, and also starting to gather some lessons learned and work on this, get the feedback in. The next point is the org-wide adoption. Yes, of course, after our proof of concept and the things we learned there, we would like to roll this out now inside the organization, something which is very important. So the things we learned in our proof of concept phase, we try now to get all over the organization. So starting here to find more teams and to roll them out. We also start mentoring sessions, because the things we learned and we want to roll out, that people repeat this process, they need to train also on this one. So something we do is here offering also mentoring sessions. And of course, we have a DevSecOps implementation which is governed and give us reports back, give us numbers back, because it's very important that there is an ownership behind the implementation, so people can come to the person and give feedback and say, hey, the current implementation, the current version of our DevSecOps or DevOps implementation doesn't fit perfectly our needs, how we can extend this, how we can work on this, that it applies also to us. And now comes the next point, is the sustained and repeatable phase in our maturity level. So we can see now that our implementation is sustained around different teams, which is very important. We have a DevSecOps governance, what I mentioned before. People know where to apply for any changes, any feedback, and then they can decide on changes. And of course, everything is tracked. We get the full observability, we get the metrics here and see how any improvements in our process changes the time to deliver, for example, and every metrics which I like to gather and to report. And of course, the last point is here the optimized DevOps one. So we have a continuous feedback cycle going on. We run everything through all the teams, and we have now we reached a state where we really can concentrate on delivering our actual value or our application value, and the whole tools and frameworks are standardized and works perfectly together. So I just picked one out and say, okay, when do we start to talk about platform engineering? Yes, it's the phase where we come into the sustained and repeatable area, where we say, okay, we want now that things are always the same. So think about when you have the cookie cutting, when you make cookies. So you have a form, and you can go to your dough and you can stick out the different forms, and you know a star will always be the same star because I provided now here the cookie cutter tool, and this is the same. So we have our DevSecOps implementation, and now there's also a governance in place. And this is the phase where we start really to talk about platform engineering. So this is my definition, and I'm sure everybody has a definition on their own. So could be a little bit different, but for me, platform engineering is a practice of building and operating a common platform as a product for technology teams. So this is my definition here of platform engineering. So let's head over to some of the responsibilities of a platform engineering team. So we see now the different phases, we see the maturity level of a platform, and we have also a definition what platform engineering is. So now let's talk about some of the responsibilities of a platform engineer. So of course, one of the responsibilities of a platform engineer is to design and implement the infrastructure, very important. Another one is provide an automation for the application deployment process, very important, because when I work on my application, I want to have a way to deploy this to my target. Very important is also provide here a troubleshooting support. So when something goes wrong or I have questions, I need to know, I need somebody who gives me the answers. I can just call up or show up in an office hour and ask, hey, I'm using this way to deploy my static application, for example, and it keeps on timeouting or whatever. How can I resolve this issue? It could be a personal session, it could be a documentation and so on, but important that we provide support. And of course there's some additional stuff, so maintaining and updating the infrastructure and the applications, and of course being always try to see what's new in the whole community or in the whole scene, what's the latest technology. For example, is there a need to switch slowly or to replace one of our pieces inside our platform with another technology? That's very interesting, and a platform engineer should always stay curious and always have an idea on the latest technology and give feedback for any future changes. Of course, we don't do this just for the lulz. It's very important to see also what are the benefits, so what are the business benefits of platform engineering. And one of the business benefits is that we reduce the toil of software development. So nothing is more worse than when people start to think that some of the stuff which is maybe annoying, like packaging your application logic, just as a very simple example as a zip file, and then putting it into some share that somebody can pick this up, or a script starts to pick this up. So this is something which we should avoid, and we should identify some of the toils and try to eliminate this one, because they are not generating money, they are costing us money, and this is important to identify and then put on a priority and say, okay, we're going to eliminate this with following future step, or the platform already eliminates most of the toils we identified during the requirements gathering phase for the platform. Of course, very important, we want to improve engineering productivity. That's very important. So the engineering teams, which are very costly, they should focus really on delivering value and not spending time on, for example, setting up the perfect subnet or setting up some security groups and so on a specific cloud provider, because they need to learn the specificas and they need to learn how to set them up. So this is something we should really try to avoid and let engineering work really on implementing the business logic, the logic which generates us revenue and money for the organization. And of course, there are some additional ones, and I think the list is not complete, and everybody has probably 10 to 20 additional points they see also beneficial for the business. But of course, here providing consistency and confidence, it's very important, so we can plan ahead new functionalities, we can release new features with confidence. For example, for the customers, and say, okay, we are 100% sure that we can really promise a new functionality, because we know that the whole platform is really has a quick turnaround and can really quickly deliver. There's no need for huge release process and so on. And of course, it helps to scale teams. So we see that, for example, one project needs additional team members. They can join because the platform is always the same, independent from A to C. There are onboarding documentations, and everybody knows how the platform is working. And at the end, we created here our internal developer platform. So we see now from the picture before, we see we have a platform engineering team who's building services, different services, depending on the needs of your own customers. Very important. And we see that the internal customers, aka for example the developers or the development teams or the product teams, they consume the services. They can order now a Kubernetes cluster, they can order now a specific landing zone for the project, whatever. It really depends on what the platform engineering team identified together with the customers, here with the developers, as a service, and then they maintain this and say, okay, version 1 of our internal Kubernetes service, here, you can order this. And some of the things we should also keep in mind here. Yes, we're using now our platform and have an idea to say, okay, of course, our platform should be built to be flexible. That's very important. It should be extensible. So as I mentioned before, when we identify that a new piece of technology comes, and it's important to incorporate this, so we see that the development team asks, for example, for a new JavaScript framework because they saw benefits for this JavaScript framework. We can implement this. We can swap golden paths. We can change specific functionalities relatively easy. And it should be cloud agnostic, which is very, very important also to say, yes, because it could be possible that we want to switch the cloud provider. And you see behind my camera, it's written composable, so the platform should be composable. And yes, now we have platform engineering. Finally, we reached our stage. We have a platform engineering team, and we can call now everything platform engineering. So now let's talk about a reference implementation I created here. So you remember we talked about Pulumi in a cloud native world. So how does a reference implementation looks like with all the feedback from our customers and all the things we see at a customer, the combination of CNCF projects and Pulumi. And here we got it now. We have the KEBAP stack. I will go into more details now about the KEBAP stack. To guide myself through all the different layers of the KEBAP stack, I use here the CNCF platform capabilities map. So we see here different areas, and let me show you how we fill them with the KEBAP stack. So the underlying layer is Kubernetes. So the KEBAP stack completely runs on Kubernetes, which is very important because we use here Kubernetes as our orchestration platform, taking care of delivering application definitions, delivering infrastructure definitions to the specific operators, for example, or to the clusters we would like to deploy the application onto. Next point for handling all the secrets is External Secrets Manager. External Secrets Manager is a very, very cool and very strong project which has many options with different providers to connect to cloud secret providers, to connect to different Kubernetes clusters, for example, to get their Kubernetes secrets. And recently we also introduced here the Pulumi ESC connection to the external secrets operator, which is very great. Next point of the KEBAP stack is the interface we communicate with our customers, with our internal customers. And here we find out that Backstage is really a tool, a project people are using and evaluating to use. So we have also a Pulumi Backstage plugin for this, and it offers us a user interface and a way to define our project templates and our documentation and make them accessible for the different people, teams inside an organization. Next point is delivering. The whole delivery, be it infrastructure definitions for the Pulumi operator, be it workload definitions and so on, is done via Argo CD. And we also use a specific functionality from Argo CD. So the KEBAP stack is built in a hub and spoke approach. So our main Kubernetes cluster acting here as a hub and is able to spin up new Kubernetes clusters and attach them to Argo CD as a spoke. And then we can use in Argo CD the application set controller to deploy our workload depending on the capabilities we defined. You will see this later in the demo with a little bit more detail. The last point of our KEBAP stack is Pulumi. Yes, we use the Pulumi Kubernetes operator here to define every infrastructure ordering. So we can define the infrastructure as a YAML file and deploy them via Argo CD to our control plane cluster. We can also define the location in a Git repository, be it Python, be it TypeScript, for example. So we have a huge flexibility here, and just deliver the definition via Argo CD to our hub Kubernetes cluster, and the Pulumi operator starts to kick off and provision our infrastructure and feedback the infrastructure details back to the person who ordered it, like a URL or a password for a database and so on. As an additional bonus for our scanning of artifacts and enforcing policies, we're using Kyverno. Kyverno is a very cool tool we see with plenty of people using in the CNCF, also with the customers when it comes to Kubernetes. And of course, the KEBAP stack is also supporting this. So as you can see, the letter K is double here for Kubernetes and also for Kyverno. Okay, let's dive a little bit more into the architecture of our reference implementation. So what I call here the ignition phase. So on the left side, we have a CI system or a GitHub action or a platform engineering team which uses Pulumi in whatever language they prefer. So my reference implementation I make accessible for everybody is written in TypeScript, but you could also define everything in Go, Python, depending on your preferences. So the platform engineering team then ignites the so-called hub cluster on the cloud of their choice, of the cloud provider of their choice. And here comes one of the cool part is that we also deploy, after the creation of the whole infrastructure, we also deploy Argo CD in a minimal version and pointing to a Git repository where every other definition of the tools we're going to use is stored there. So we have a separation, we have the ignition of the hub cluster, we have the minimal Argo CD, and then pointing to the GitOps repository with all the other applications to fetch from and to deliver into our Argo cluster, including Argo on its own. So there is no need anymore to go back to the code base, for example, updating Argo CD. So you can put the version of Argo CD inside the Pulumi code on a ignore flag and say, okay, don't report me a drift, for example, when I update the Argo definition inside my GitOps repository, which is also very, very cool. So how does it look like the ordering of one use case? So for example, we would like to order a development Kubernetes cluster, and because we are frugal and we want to take care to not spend unnecessary amounts of money by provisioning a Kubernetes cluster with one of the cloud providers. For example, we opted here for a vCluster. So team A comes in, opens Backstage, selects they want to use a dev cluster. Backstage then renders the golden path, which our platform engineering team created, creates a pull request in a Git repository. Then the platform engineering team or another person can look on this pull request, can say, yes, that's fine, I'm going to approve this. The moment it gets approved, Argo CD sees a change and then deploys the definition of the vCluster to our hub cluster. The vCluster gets created and, as I mentioned before, gets automatically attached as a spoke cluster to Argo CD, ready to deploy any applications. We will also see this in the demo. Next point is what happens when we would like to order a real in quotes Kubernetes cluster. Same workflow. We go to Backstage, select the software from the software template, the ordering for a Kubernetes cluster, go maybe to a specific element and select, hey, I would like to order a productive cluster. And here comes the next rendering. So Backstage renders a different software template where, for example, a definition for Pulumi is also inside. So using, for example, EKS, there's the Pulumi definition of this. Creates the pull request, same flow, pull request gets reviewed from the specific team, so from the platform engineering team. You can also omit the pull request, you can directly go to maybe the main branch, but this is something every company has their own rules and processes behind this. So in this case, yes, creates a pull request. The moment the pull request gets approved, Argo CD again detects a change, rolls this out on our hub cluster, and now the Pulumi operator detects now, hey, there's a custom resource. I am watching out for this, so detects this and rolls everything out on the specific cloud provider, creates the Kubernetes cluster. And again, the moment the Kubernetes cluster gets finished, we then attach this Kubernetes cluster as an additional spoke cluster to Argo CD, ready to roll out also applications depending on the capabilities. Last but not least, what happens when we want to order, for example, additional cloud infrastructure, which is not fitting now into the whole Kubernetes thing, for example, a function, or we want to order a Kafka queue, and so on and so on. Same flow, go to Backstage, select from the software template the specific template we would like to have, for example, for our Kafka cluster. Backstage creates a pull request. Argo CD again detects any changes on the main branch the moment the pull requests get merged. And again, as we defined everything with Pulumi, there's another Pulumi definition, for example, the Kafka queue or an SQS or whatever you want to provision into your cloud provider, detects and rolls out this cloud infrastructure and gives you feedback via Backstage that, for example, the URL and so on for further use inside your application. So after all this theory, let's see how the KEBAP stack performs with a little demo. So welcome to the demonstration. So as you can see, everything is deployed from our KEBAP stack. We have Argo CD, we have Backstage, we have the external secrets operator, Kyverno. Everything is here in place on our Kubernetes cluster running on AWS. I port forwarded Backstage in the Argo UI. So heading over to the Argo UI, we can now see, if we head over to our templates, we can see different templates. These are the different services the platform engineering teams provided. If we head to our create button, we can see now more details about the services. I'm going to choose now the Kubernetes cluster on DigitalOcean because we can see here now the Pulumi operator in action. So I'm going to choose, give it a name, select a stage, the owner, development team A. I can review here now and see, yeah, that's fine. See the logs and see that a pull request is created. I head over to the pull request. I see some additional informations around the code. In this case, everything is defined as YAML using the program CR. So I can now say yes, squash and merge. Everything is fine. And if I head over to Argo CD, let me just kick off that it's quicker deploys everything. So we see the app of clusters here is out of sync and everything is rolled out. We see now that the definition of the cluster is rolled out on our Kubernetes cluster, ready for the Pulumi operator to pick up. So if we head over to our app cloud, we should see now that here the My Docs cluster stack is picked up from the operator. And if we head over to the deployment, we should see now that everything gets deployed. This will take a couple of minutes and I will get you back on board as soon as the Kubernetes cluster is up and running and attached to our Argo CD as a spoke cluster. Okay, so now the Kubernetes cluster on DigitalOcean is deployed. Everything is created via Pulumi. We can head over now to Argo CD and see if Argo CD has now the Kubernetes cluster from DigitalOcean attached as a spoke cluster. So we head over to our cluster section and we see, yes, the DigitalOcean cluster is connected. If we look some of the capabilities, we see the team belongs to deployment A. We see the environment is for production. We see the cluster types of DigitalOcean. You can add additional labels to say, okay, this is only for backends, for front ends, and so on and so on. And now you can think about deploying applications depending on capabilities of the different cluster and not picking out specific clusters by name. We see it's also connected version 1.3.0. So we saw in the demonstration how Pulumi works with CNCF projects here in the selection of the KEBAP stack, but there's also something I would like to mention, the reasons why not to go DIY and build your own IDP. As you can see, I used here different tools and created all the integration on my own. So what could be some of the reasons to not go? So as you saw, and probably guessed it, the complexity of IDPs, it's not that easy. IDPs may look easy from the outside, but they are a beast on its own and needs a lot of knowledge and a lot of brain power to keep things moving. So the complexity of IDPs is definitely something to consider when going DIY. Technical debt accumulation. So when we build something, we also start to accumulate technical debt, and it's the same with our IDP. And yes, we need to spend a lot of time in our IDP to keep the things moving, keep the things working. So if there's an update with Argo, we need to take care that when we update Argo CD, for example, that it's still everything is working, that the integration with Kyverno, the integration with Pulumi operator, with Backstage is still working. Updating maybe any plugins we need, for example, in Backstage. So we have to spend a lot of time to keep the lights on with our IDP. Limited external integrations. Yes, there's always the problem that we can maybe not integrate every tool we would like to have. We use inside our company, ServiceNow or whatever tools, Jira, with our own built IDP. So maybe we need to create additional glue components just to make the communication between external tools. This also adds again to technical debt and to the time we spend and the complexity risk of DIY. Not everybody is a security expert, so that's something to keep in mind. So maybe we did not thought about this, maybe we did not order a penetration test from an external company to be sure that there are no security risks. So we could end up with a security leak which could be very harmful for the company. Of course, in big enterprises, governance and compliance is always a topic, so we need to take care that our DIY is compliant and to some frameworks, for example, and then also following here a governance. And I mentioned this before in the other parts here, we have to be constantly updating our IDP and maintaining our IDP, which takes time, costs, and manpower. Last but not least, we have to we should retain the expertise here. So we need to take care that people who have a deep understanding of our IDP, not leaving the team, for example. New team members have to be quickly trained to understand how our IDP is working, which is maybe something takes away to deliver value for our customers. I mentioned this before. So, and to give you an idea about this and to see how IDP could look like, we created a reference architecture for large-scale organization using Pulumi Cloud. So the Pulumi Cloud offers a huge functionality around IDP, so you can use the Pulumi Cloud as your IDP, where every piece of the stuff I mentioned in the KEBAP stack is already taken care. So you have policy as code, you with Pulumi CrossGuard, you have secret management with Pulumi ESC, you have Pulumi deployment for deploying your applications and your infrastructure. So all the pieces are there for you to use. And keep an eye on our new series, Pulumi Patterns and Practice platform. And there will be a lot of blog posts and a lot of videos. And yeah, with this said, thank you. And yeah, talk to you soon.